Hey, good morning. This is gonna be, man, my hair looks a mess. This is gonna be a lesson on, it's gonna be more on electron configurations. It won't be nearly as long because I won't have to cover all the background stuff. We just kind of put some loose ends together. So it's important that you watch this, but just some loose ends, and it'll be pretty short. Some exceptions, some clarifications. All right, so I'm gonna go ahead and share my screen. Do that. Let me do my thing on this end. Come on, come on. Oh man, it's not working. There we go. Okay. Go here. There we go. So we have learned we have been learning about the Aufbau sequence. Okay, and that Aufbau sequence, if you recall, told us the order in which electrons fill orbitals. Okay, and we used the sequence to write electron configurations. All right, this, if you don't realize, is the Aufbau sequence. All right, that's your Aufbau sequence. It told us that we go to the 1s orbital, and then the 2s, and then the 2p, and then the 3s, and then the 3p, and then the 4s, and the 3d, the 4p. Right? That is our Aufbau sequence. We related it to the periodic table. We said 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, 5p, 6s, 4f, 5d, 6p, 7s, 5f, 6d. Right? That is our Aufbau sequence. Now, a couple of things that I need you to realize. You will have questions as such, and I want to make sure that you understand them. This is also the Aufbau sequence, right? Here is your, let me get my highlighter again. Here's your 1s. Here's your 2s. Here's your 2p. Here's your 3s. Here's your 3p. Here's your 4s, 3d, 4p, 5s, 4d, 5p, 6s, 4f, 5d, 6p. So what you need to realize, let me clean this up, is that from bottom to top, we are gaining energy. So down here is a low energy, all right? And up here is a higher energy, okay? And it's in that order. So we can see that the low energy, the lowest energy is the 1s location. So the s orbital on the first energy level is the location where electrons have the lowest energy, all right? Now, after that, we know comes the 2s, right? As you see, 1s, 2s. And then the 2p has a slight bit, I don't need 2p's. The 2p has a slight bit more energy, even though they're both on the second energy level, right? And then on the third energy level, we have the 3s and the 3p. Well, after that comes the 4s and then the 3d, right? So electrons actually fill up this orbital before they enter the d orbitals on the third energy level. The reason for that is because it's a lower energy location, okay? And you just need to be aware of that. That's this, right? So after the 3D, right, comes the 4P. Then comes the 5S, then comes the 4D. So you can see that here because the 5S is here and the 4D is here. And the 5S is lower than the 4D, right? So it has, therefore, it has less energy. If this doesn't make sense, you need to bring it to class. But if you just read this diagram up, you will see the order of energy of the orbitals on different electron levels, different energy levels, I'm sorry. Okay. So I can see that the 4F has less energy than the 5D, has less energy than the 6P. I could also see that the 4P has less energy than the 5S, has less energy than the 4D, has less energy than the 5P. Whatever's lower down has less energy. It's a less energy location. The electrons there are more stable. Okay, I'm going to leave that at that. Remember, I just said I was tying up some loose edges. That is why electrons enter the 4s region before they enter the 3d region, and then they go back out to the 4p region. The 4s is lower in energy than the 3d, and then they go to the 4p, which is raised in energy again. So electrons prefer a lower energy location, and that Aufbau sequence provides us with the order of the energy of different orbitals and energy levels. A lot of vocabulary words here. Now, the next thing we're going to talk about are the exceptions to that rule. All right, so these are the exceptions to the Aufbau sequence. All right, and the exceptions tell us, right, there are ways for scientists to measure where these electrons are located, and that's how they've figured out this information. Oh, there's an energy level here, and this is how much energy those electrons have. So it's called photoelectron spectroscopy. All right. Now and through this, they've learned that, hold on, everything doesn't always do what we expect it to do. So there are exceptions to these expectations. And what we see is those exceptions have to do with half-filled and completely filled subshells, okay? And those are preferred. And what that means is we have seen through our exceptions that there therefore must be something more stable about this particular arrangement. Okay, and this won't go on for much longer. We'll be about finished here. Our first exception will be copper. Okay, let me look at my periodic table, make sure I'm right. I'm pretty sure it's copper. Oh, no. Okay, yeah, that'll be copper. A copper is atomic number 29, okay? And the expected configuration will be this, and I'm going to bust this out pretty quick, okay? We would have 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d9. And those are going to add up to 29. Those are where the electrons would be located. But you can see here, what I need you to realize is if there was one more electron, then it would go 3d10. Now this is a filled subshell, right? 10, the D subshell only holds 10 electrons. So this is a filled subshell. And what we expect to see is what we just wrote, the 1s2, and we expect it to end 4s2, 3d9. But what we actually observe when we look at a photoelectron spectrum of copper is we see 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d10. So we see that there is a difference between what the Aufbau sequence says and what is actually observed. And the difference is this is now half filled and this is now fully filled. And that is in fact what that copper atoms configuration looks like. It actually looks like the second one here. Okay, if I could go up to my periodic table, I can show you that copper lives right here. Okay, and if you see that this is 3D, this is 3D 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What that means is everyone right here would have the same exception, right? Copper ends in 4s1, 3d10. This element, it's going to be silver, will end in 5s1, 3d10. Okay, so that trend is going to occur all the way through here. Now, the other place we're going to see that trend is occurring right here. All right, and that's going to be chromium. So let's go back down and look at our second exception. All right, make a different color. Second exception. Was this a exception to the Aufbau sequence? Okay. I don't know why I dotted that because there's no I there. And this would be chromium? Yeah, chromium. All right. And what we expect to see, expected configuration for chromium, which is atomic number 24, is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d4. That's what we would expect, right? That's what we would expect. Well, notice that this last subshell on the third energy level is almost half filled. And if you recall, there's something particularly stable about half filled and completely filled orbitals. So what is observed the observed configuration is the 1s2, the 2s2, the 2p6, nothing changes till we get to the end. And here, once again, we've got 4s1, 3d5. So this is the actual observed configuration. And what we see is both orbitals, or both subshells rather, are half filled. Okay? And that is going to be the case for every element that lives in this group on the periodic table. They're going to have an exception. So we've said these will have the exception and these will also have the exception. Okay? So we've talked about how we can use the Aufbau sequence to determine which orbitals have lower or higher energies. And this is the low energy and this is the high energy, right? They always fill the lower energy orbitals first, and then they fill the higher energy orbitals. There are a couple of exceptions to that rule, right? And those exceptions lie with the elements that live or reside in this group here and this group here, right? The first of the two groups does not end in what we expect. Instead, we see that one of these electrons has come here to give us a 4s13d5. The other exception, we expect this, but we see that one of these electrons has come here to give us a 4s13d10. And those are exceptions you just need to memorize. It's just those two groups, okay? And that's the only place we need to worry about that. Okay, that was it. That's a short one. Okay, see ya. And